everyone, my name is Meilisa, with NIM 2510110300045, from Mathematics Class A. The Binary Foundation. Have you ever wondered how a machine thinks? The answer isn't magic, it's pure mathematics. At the most fundamental level, computers do not understand numbers, images, or words, they only understand electricity. Computer logic begins with the concept of binary, a base 2-number system consisting only of 0s and 1s. The number 1 represents a true state or the presence of electrical voltage, while 0 represents false, or the absence of voltage. From these two simple states, the entire complexity of the digital world is constructed. The logic gates to process this binary information. Computers use physical components called transistors arranged into logic gates. There are 3 basic gates that serve as the main pillars. AND gate produces a 1 only if both inputs are 1. It's like a door that only opens if 2 people turn their keys simultaneously. OR gate produces a 1 if at least one of the inputs is 1. NOT gate, an inverter. If the input is 1, the output is 0, and vice versa. Boolean algebra and complex circuits. This logic is based on Boolean algebra, a mathematical system developed by George Boole in the 19th century. Inside a computer, thousands to millions of logic gates are combined to form larger units such as adders, for addition, and flip-flops, for storing memory. When you press a key on your keyboard, these sequences of logic gates work at lightning speed to convert that electrical signal into a binary code that the processor, CPU, can understand. If battery is less than 10%, then turn on power saving mode. This is pure logic executed by the machine based on the input it receives. This is why computers are so consistent, they follow logical rules without exception. The arithmetic logic unit, ALU, the brain within the brain inside every processor, CPU, there is a vital component called the arithmetic logic unit, ALU. If the CPU is the brain of the computer, the ALU is the part of the brain responsible for critical thinking. The ALU uses thousands of logic gates to perform 2 main tasks: arithmetic operations, like $A plus B$, and logic operations, like comparing if $A greater than B$. Every time you play a game or edit a photo, the ALU performs millions of logical comparisons per second to determine the color of every single pixel on your screen. Logic in programming languages, abstraction. As humans, we don't write scripts in binary 1s and 0s. Instead, we use high-level programming languages. However, the underlying logic remains the same. Computer logic in software utilizes comparison operators and logical operators. Comparison equal to $equals $, not equal to $. Equals $, greater than $. Combination logic linking multiple conditions together, e.g., if user has a ticket and seats are still available. This is what we call an algorithm. An algorithm is simply a set of logical instructions arranged in a specific sequence to solve a problem. Without proper logic, software encounters bugs or malfunctions. The future, beyond binary, quantum logic. The world is moving toward quantum computing. Unlike classical computers that use bits, 0 or 1, quantum computers use qubits.